Hi, in this video we're going to talk about optimistic concurrency, and in order to enable this there are two database options that you need to be aware of. Before we get into the database options, it's a good idea to understand why we need optimistic concurrency in the first place. Now, if you've been working on very large database systems and especially highly transactional database systems, you know that blocking issues are fairly common in these environments, mainly because concurrency gets affected as the number of users and transactions increase. Primarily, you'll find this kind of behavior in tables that are used for things like a shopping cart, order placement, ticket reservations, etc. And the reason why we have that issue is because a reader and a reader use a shared lock, so they never really lock each other or block each other. But a reader and a writer require exclusive locks because the default behavior is pessimistic concurrency. So while a reader can approach SQL Server with a shared lock, a writer, like an update statement or an insert statement, requires exclusive locks. And this is a problem because locks are given on a first come first serve basis. So you might have a situation where there's a long running query and that acquires a lock for the duration of the time period of its transaction, and as a result everybody else has to wait. This, as you can imagine, causes performance issues because others who are just doing a select statement obviously end up having to wait in the meantime. And this is a good behavior because it basically ensures the basic primary principles of databases, which is the ACID properties. And the way that we're able to achieve these things is by implementing things like locking. However, as the database environments have changed over the years, it's become more important to have environments where a slightly higher amount of concurrency is available. And naturally, the first step is always good design, good indexing, etc. But once you've reached the limits of what you can do in that space, then you might want to consider enabling optimistic concurrency. Now, in order to do that, what you need to do is you need to enable read committed snapshot on and allow snapshot isolation on. So before we do that, I'm going to show you an example of what the database looks like, or how behavior looks like when you don't enable these, and then we'll talk about what happens when you do. So I've got a database. I'm going to create one. It's called Optimistic Con, and inside this I've got a table that I'm going to create now, and I'm not running this part of the script. I'm just going to go ahead and insert one row of data. I'm going to insert about 50,000 rows of data into this for the time being. And while that's happening, if you look over here, I'm going to go ahead and open up the select statement and do a count of rows in this table. And you'll see that I'm getting the data at the moment because essentially what's happening is after every insert there is a commit happening. So as long as the commit happens, we know that the data is good. Now, what happens if I don't commit the transaction and I just do a begin followed by an insert? In which case, because the commit transaction is not yet run, this can be treated like as if it's a long-running query. At this point, if I try to do a select count star from the table, you'll see that the query just keeps on executing. It's not really giving me any results because it's waiting for this query to finish committing its transaction. And the reason for that is because the default behavior in SQL Server is to read committed data. That's the default isolation level that we have there, and it's waiting for all the data to be committed before it can read, and that's where the performance issue comes from. Now, in our case, I can simply go ahead and run commit transaction, and when I do that, you'll see immediately the second query finishes and I have my output. And it's okay if you can go ahead and do your transaction management properly, but if that doesn't happen, you can see how this causes an issue, performance issue for everybody else. So to avoid this, what we're going to do is we are going to go ahead and change the database properties to enable read committed snapshot and allow snapshot isolation on. These two database properties can be found in the database options, so you can right click the database options, go to properties. Just give me a second, let me change this guy here real quick. Let me just go ahead and cancel this guy. And if you want to see the properties, you need to go into options, and under options, if you look, you will see allow snapshot isolation. I've just set it to true, and is read committed set to true. So now with these two properties set, let's try the example that we did before again, where I'm beginning a transaction and inserting some data, but at the same time I'm not committing it. So because I don't commit it, the lock remains available with SQL Server. Or with this session, basically. There we go. And again, just like before, I'm inserting data, I've acquired locks, but I've not released them. But at this point, you'll see that even though the transaction isolation level is still set to read committed, you'll see that at this point, when I run this query, it doesn't take as long as previously to return the output, because it's able to read whatever data is already committed. And at this point, I've got 33,166 rows that are committed, and it's only the one row that I've inserted here that's not committed, so it's able to get me the data that I want. And this is how we're able to achieve concurrency by enabling optimistic concurrency. Now, you can also go ahead, this behaves the same way for update statements as well. So you can see that if I run the update statement here, where I say I'm just picking up 1,000 rows in random and changing their customer name to new Jayanth. So I'm going to run this, and if I try to do the select statement, you'll see that I've got my rows available here. If you want to see how this data is stored inside the version store, which is basically a copy of the data, you will see that it's available by running this query, where we are looking for unallocated extent pages, version store reserved pages as the column, which will tell us how many pages are available in the version store in tempdb. There is a newer DMV that you can use, which will basically, because here in tempdb what happens is we don't know which database is contributing significantly to the version store. Whereas if you run this DMV, which is sysdm tran version store space usage, you'll know that the database with the database ID 5 is the one that's contributing significantly to the version store. So this is actually something that you want to be using to identify which are the databases that cause the version store to blow up. At this point, I need to go ahead and insert a warning or a caveat. Now, in older systems, we never used to really implement this because the overhead on temp database was significant. And in temp database, you want to be really careful about what you do there, because as you know, the temp database is used by not just your database, but hundreds of others as well. And any performance degradation that happens at tempdb affects everybody else. So you might not want to go ahead and do it on a server where you're only looking to improve performance for one database. So previously, we never used to do these things because the benefits that we used to get by enabling optimistic concurrency might not outweigh the drawbacks for other databases. However, new versions of SQL Server have a number of improvements to optimize temp database, and this revolves mainly around the allocation pages and contention around the system pages basically. We also have additional database files being created, etc. So a lot of the optimizations is being done for you in advance, and as a result, it's a lot safer now to enable optimistic concurrency than it was before. Previously, there was a lot of monitoring that you had to do, and you still need to do those things, but it's a lot safer at the moment to use optimistic concurrency. Now, the reason I'm showing you this is because a lot of systems, what happens is you've got these things going on, the servers are not being upgraded because they're legacy systems, and you reach that limit where the hardware and the indexing and the design have reached a point where they're not giving you any more benefit. And at that point, you might want to consider using optimistic concurrency. And what that'll do for you is just increase the amount of work that can get done at the same point in time, having kept in mind the fact that you need to go ahead and improve or provide some provisions for tempdb. And in a lot of cases, what I see when I do consulting for companies is we don't necessarily remove it, we add an additional SSD or a persistent drive and a flash drive basically, and we allocate the temp database files into that drive to improve the IO throughput of the tempdb, and that in itself gives a significant performance boost, along with other features like buffer pool extensions, etc. So this is one of the things that you want to watch out for in your database. Again, there are other ways that you can do it. A lot of cases I see nowadays, people have switched from using tables or persistent database tables and switched to in-memory OLTP tables for things like shopping cart reservations, etc., just so that they can really massively scale the throughput of transactions that happen. And that's definitely an option depending on which version of SQL Server you're using, and some amount of code rework that you might need to do when you're working with in-memory OLTP tables. So that's kind of pretty much what I wanted to show you with in-memory optimistic concurrency. Before I leave you, I do have a request, and that is, if you did enjoy this video, I'd like you to go ahead and subscribe to the channel. And the reason I'd like you to do that is because I need about 1,000 subscribers to do live streams on YouTube. And considering the recent COVID-19 epidemic, it's becoming a bit of a challenge to push these videos out regularly because of the lack of resources. Doing a live stream will allow me to do it a little more off the cuff, and that will definitely make it easier for me to publish more videos out there, or publish more content out there really quick without having to go through the whole production value process as such. So if you do have any questions about this, I'd like to hear it. Please go ahead and add a comment and let me know if there is any other topics that you want to cover, or any more in-depth understanding that you require as far as features in SQL Server are concerned. I hope you've enjoyed this video, and thank you for watching.